Hello, this is the Monte Carlo dice demo for DEEP Physics 2026. Now, for purposes of this demo, we have a couple of different objects. We have a 4, 6, 8, 10, 12, and 20-sided dice, a massive acrylic dice tray, in order to try and keep the dice on the table rather than on the floor during the physics festival, as well as a massive piece of scaffolding with a funnel and a camera attached to it, so we can drop from and get a bird's eye view while we are playing with dice. Now, it should be noted that while many dice demonstrations focus on the side a dice lands on and probability, for example, for a 6-sided dice, you have a 1 in 6 chance of getting a 6, or a 3, or a 4. You get the idea. However, for this demo, we will be instead focusing on how the different geometries of the dice, and in particular, how the increasing number of faces and edges, as we increase the number of sides on the dice, will affect how far and how random their motion is. General idea, in the end, we'll conclude that there's probably a good reason that most games use D6s rather than D20 if you want to keep the game going rather than have your dice all over the floor. Now, easy way to demonstrate this, take two pretty good middle examples. Take a 6 and a 12-sided dice. For our purposes, we will have a little bit brighter colors, a purple 6-sided dice and a yellow 12-sided dice. If I roll them both forward from the same hand, 12 goes a little bit further, 6 stays behind a bit more. Once again, 6 stayed behind, 12 rolled further, and we'll notice had a odder arc of motion. Now, this is not a guaranteed outcome, however, it is more likely that every time the dice lands on the table while it's rolling, that the 6-sided dice is more likely to land on a face and come to a stop, while the 12-sided dice is more likely to land on an edge or corner and continue rolling. As we just demonstrated, this works moving forward. However, it also works if we just drop straight from the top, from our funnel. We're going to be using a white D12 because I just dropped my yellow one. Anyways, dropping from the top with the D6. Moves quite far, bounces a little bit, so it's kind of close to D12 stayed fairly close. As we see, this pattern does not always work. However, we keep rolling. 6 stayed a little bit closer this time. One more time. 6 stayed fairly close. Our 12 rolled out back to the rest of them. As we noted, this doesn't happen every single time because there's still always a chance that we'll land on a face and stop with D12 or D20. However, the general pattern stays the same. Now, at the moment, most of the demo is focused on just visual evidence and common sense, increasing number of sides and faces, more likely to keep rolling. However, going forward, I would like to develop tracking software so that we can track the motion of each of the dice, both the path that they take and their starting and ending destination, so we can get more conclusive evidence to this pattern. And then also like to follow through on the name of this demo, Monte Carlo, and create a Monte Carlo simulation that focuses on how different geometries result in different paths and greater distances. Anyways, thank you.